Bismillahirrahmanirrahim. Starting with the second method of solving recurrence equation. This is substitution method. So it's a three-step method in which first of all we do a guess, and for this guess there is no rule. So just looking at the equations and solving it, you will be having a good guess. But if you are not doing a practice, then you were definitely going to have a bad guess. Bismillahirrahmanirrahim. Starting with the second method of solving recurrence equation, that is substitution method. In this method, first of all, we mm, take a guess of, we look at the equation and then we guess that this would be the answer of this equation, and then we verify that one, and then after that we will solve it for the constants. And if it is not verified and solved with for the constants, then we make another guess and then do the same one. Let's do it with an example. Hopefully then you will be able to understand it in a much better way. So in an example, we take a little bit tough example for that one. So t of n is equal to 4t of n by 2 plus 100n. And just looking at this one, because if we will be having some experience on doing this kind of work, so we would be able to give a good guess. But let's say I just give a wild guess on this one, and for the worst case time complexity of this one, so I mark my guess as, so my guess is big of n cube. So I say that the answer of this equation is big of n cube. If I was going for the theta or omega, then I would be doing something different, but definitely all the steps are the same, but the equation inequality would be changed. So if this guess means what means t of n is equal to big O of n cube. This implies that t of n is less than equal to cn cube, and this is what I need to prove. I have to prove it. Let's start with this proof. Okay, so our original equation is t of n is equal to 4t of n by 2 plus 100n. Okay, now what I need is, I need to replace this t of n by 2, but now I'm going to replace it with what I have assumed, or what is my guess. So my guess was that t of n is less than equal to c of n cube. Here I just replace n with n by 2, so I will get t of n by 2 is less than equal to c n by 2 whole cube, and this is what I'm going to replace in this equation. So I will get t of n is equal to 4 times t of n by 2 is replaced by c of n by 2, so it is c of n by 2 whole cube plus 100n. So now, because of this one, because this part is greater than t of n by 2, so overall we replace it with this one, it will also become greater than t of n. So here we have to mark this one, but this is going to be equal to what we are going in the next part. Here 4 is crossed with cancelled with 4 here, and the only remaining part would be 2. C of n cube divided by 2 plus 100n. So this is what we have achieved. So you can see here I was required to prove this part. This is t of n by t of n is less than equal to c of n cube. So here I need this part is less than equal to c of n cube. T of n is less than equal to t of n cube. So here I can say that my required equation is, if I want it to be big of n cube, then my required equation should be t of n is less than equal to c of n cube. So now I need to convert this whole expression into this part. Now, how can I do that one? Okay, the easiest way is I just add c of n cube. I just add c of n cube and then I subtract c of n cube. So I'm going to do that one. C of n cube by 2 plus 100n plus c of n cube minus c of n cube. So on the right hand side I need c of n cube, so I just do it like this one, c of n cube, and then I simplify the rest of the one. So this part is gone this way, so this is c of n cube minus c of n cube, so it will be minus c of n cube by 2 minus 100n. I just close this one. So if you multiply this minus with this one, so it will become this plus. So you just subtracted minus cn cube and from cn cube by 2, so the rest would be half of c of n cube, so that is this one with a negative sign. So here we can see that this is what was my required part, because I need it here, and this is what is called the residual, the remaining part. Okay, before we move on, okay guys, before moving to the next part of this one, so just explaining a concept that's going to be used in the next part. Let's say we have an equation a is equal to b minus c. On the basis of this equation, can I write a is less than equal to b? Yes or no? Just stop it and stop this video here and just think about it, whether you can give its answer or not. Okay, so if you have given it a thought, then you might be facing two kind of scenarios. What if c is greater than 0 or c is less than 0? There are two different scenarios. If c is greater than 0, so that means you are subtracting something from b, and then this part would be equal to a. That means you are reducing b and then that part would be equal to a, so that means a is greater than b. Are you getting my point? So then its answer would be no. And what if c is negative? So this, the negative of c and this negative will become positive, so you are adding something into b and then this whole part would be equal to a. So it means the only b is not enough for a, so a is less than then it would be the other way around. So here you can see that A is less than equal to B if and only if C is greater than or equal to 0. Hopefully you can understand this thing. Okay, so now assume that this B is this part and this C is this whole part, and there is minus between these two. So you can easily do this thing. Now, so we have established this fact that if A is equal to B minus C, then A would be less than equal to B if and only if C is greater than equal to 0. So because we are requiring that it should be less than equal to Cn cube, so it is possible if and only if the whole residual part is greater than equal to 0. So just put it, so if and only if Cn cube by 2 minus 100n, the whole thing is greater than equal to 0. So we just need to solve it for to constant, that is C and n. Okay, so just doing the same thing that we have been doing in the previous lectures, calculating the value of C and n naught. So just doing some simplification, crossing n from both sides, from here and here and here, and putting C is equal to 200, because less than 200 it is not going to prove it true. So we can have any C. So any C greater than or equal to 200, so that would be working for this one. So putting it the value of C here, you can easily find the value of n greater than or equal to 1. So it means that our guess is right, that is big of n cube, because we have found the value of n and the value of C. So now it is proven. Let's do another example in a very quick way. I have only this part of page to do the rest of the work. So let's have a different kind of example, that is t of n is equal to t of n minus 1 plus n, and we guess that its time complexity is big of n square. Here we can see that our required part is that what we need to prove is t of n is less than equal to Cn square. We just do the rough work on this side. So this is t of n is equal to t of n minus 1 plus n. Okay, starting from this side for the example, t of n is equal to t of n minus 1 plus n. We need the value of t of n minus 1 here, so we get it from here, replacing n with n minus 1. Okay, so it will become t of n minus 2 plus n minus 1. Sorry, so I mixed it with the iteration method. So we have to replace it with this part of the equation. So replacing n with n minus 1 and n with n minus 1, so it will become t of n minus 1 is less than equal to c of n minus 1 whole square. Replacing it with this term here, that is c of n minus 1 whole square plus n this one, and then opening the square, so it will become n square plus 1 minus 2n plus n, then this cn square, putting it aside, and rest of the terms with a negative sign. So it implies that t of n is less than equal to c of n square. So that is required if and only if 2cn minus c minus n is greater than equal to 0. If we can get two constants, that is the c and n, we can say that our guess was right. So if we put c is equal to 1, what we'll get here, so 1 here, 1 here, so it is 2n minus 1 minus n greater than equal to 0. It implies 2n minus n is greater than equal to 1. So we'll move this one towards the left right hand side. So here we can see we can find two constants, and c is equal to 1 and n is greater than equal to 1. So it is moving towards the positive numbers. That's what that we have already discussed, that this term is, this inequality is very important for us to discuss. So it means our guess is right, is right. So we can say that this equation is of big of n square time complexity. So in this lecture I have worked on two examples. One is with the reduction in using the subtraction, and the second one is the division, the recurrence using the division one. So hopefully you can understand this one, and if you are still having some questions, please mark the time end of the video and put your question in the comments. I will be answering. So hope you will be able to understand this one. Thank you guys, thank you very much. Allah Hafiz.